Hi everyone, welcome to this series of Let's Code. In this series specifically, I will keep things very concise and to the point because I'm sure if you're here to learn something and not hear me talk about random things. So let's get started. We're going to be building this thing called Schedule Visualizer, and it is a system that will control your home smart lights based on the current Google Calendar event color. So, for example, if you have an event set up from 9 a.m. to 5 p.m. that's colored blue in your Google Calendar, the system's gonna know that that's the current color and it's gonna change the color of the smart home to that color. So, if you have another event set from 5 to 6 p.m. that's colored green, the system's gonna set the color of the lights to green. Now, why do I want to build this? I work remotely 24/7 and the environment is always the same. And because the environment's always the same, it's very easy for me to lose track of time. And when I lose track of time, I find myself difficult to focus when I work or focus even when I try to take a break because the environment looks the same. And it almost feels like I haven't left work or I haven't left home from work or for work. So I realized that changing the light condition helps a lot with that. So that's why I decided to build this. So let's talk about a quick overview of this architecture that we'll be using. Initially, we need Google Calendar service. We need some sort of server that will get the data from the service, and we need for it to talk to our lights to set the colors to certain colors based on the event data. And the lights are controlled by a hub from Philips Lights Hub. And I will go in more details on how this portion works in the next video or the next later videos. But we'll be focusing on how this portion is going to work. And it's actually one of the most complicated portion out of this whole project. Now, I will get to how this leads into the topic of push notification. So, just to talk about the basics of why push notification even exists, I will explain in this context. So, our server somehow needs to know when there is a new event that's been created or modified. Now, how does the server know that something has changed in the Google Calendar service? Well, easiest way to do it is to ask constantly, right? Just like, hey, get me the latest data of all the events right now. The thing is, we want this system to be in real time. So, in order for the server to have the latest data, it needs to keep asking the service to give me the latest data, right? Now, that's first of all very nosy and very inefficient. And the service is going to be blacklisting you essentially because it looks like a DDoS attack, right? Because if you keep bothering it, it doesn't like it. So what we need is this thing called push notification service, where the server, like our server, isn't the one asking for data, but it's the Google Calendar service, the one going to be telling the server, "Hey, we have new data. Come get it." That's all it is, really. But how does the calendar service let the server know, right? And the easiest way to do it, and I think this is pretty much the industry standard, is to provide an API endpoint, like an HTTP or HTTPS API endpoint. To create or expose API endpoint of the server, we need to, well, obviously need a server that exposes this API point, right? But this is where things get really complicated. Our server, it's going to be built on Raspberry Pi, which is going to be sitting within our local network, right? And we can kind of look at it like this. And this line is our firewall. or ISP security, all this stuff that protects us from the outside world. For our server to be able to expose an API that's accessible by the Google Calendar service, we somehow need to get through this barrier, right? And one way to not to do it is to break this barrier and expose your whole local network or your server even to the whole world of internet. Don't do that, please. It's tempting, but it's a terrible idea. What we're going to be using is something called, that I think everyone knows, it's called a VPN, which essentially creates like a tunnel that safely connects our server to the world. Now the issue becomes, how do we connect this VPN to a Google Calendar service? It's not that we can have Google sign up on our own VPN network, right? So we can achieve this by using a third-party service called AWS, which is going to work as a proxy for us to expose our endpoint, but not really. So think of it this way. We're going to connect our VPN to our AWS service, which is pretty safe and pretty well established. And AWS is actually going to be the one that's connected to the world, and it's going to be the one creating and exposing an API point that can be connected by Google service. So I know this drawing sucks, but let me kind of quickly backtrack how this is going to work. So when the Google Calendar service, let's say you create a new event on your calendar, the service is going to hit this API point to AWS, and AWS is going to hit your API to your server, and that's how our server is going to know when to get the data from Google Cloud or a calendar service, and it's going to change all the lights accordingly. So yeah, that's the quick overview of this whole thing. Now you see why it's a little complicated, because yes, there's this gray area of the AWS world, there's a gray area of the VPN world and all that, but we will jump into that in the next video, which is where we're going to talk about which VPN that we're going to use to be very safe. And quick trailer is, this VPN isn't like a traditional VPN that's unsafe and attackable, but this one's actually way more secure because it's peer-to-peer VPN. So that's cool. It's called Tailscale. And AWS is going to use a thing called Lambda and Docker container, which connects to our VPN safely, peer-to-peer. So yeah, thanks for watching this far. I know this diagram sucks, but kind of makes sense, right? If you have any questions, please leave any comments, and I will try my best to answer anything. And please hit like and subscribe, and hit that ringer bell. I don't know if that actually helps with the algorithm, but yeah, thanks for watching.